Hello and welcome to this webinar on coating adhesion testing methods and equipment. My name is Bill Corbett with KTA Tater Incorporated in Pittsburgh, PA, and I'll be hosting this webinar for you today. During this webinar, we'll be discussing a variety of topics related to adhesion testing of coatings on metallic surfaces, including why the adhesion of coatings and lining systems is assessed, what property of a coating is being measured when it is being evaluated for adhesion, how to select an adhesion testing method, how to measure the adhesion of coatings using the tape and knife tests, how to measure the pull-off or tensile strength of a coating system using 5 different testing instruments, some common pitfalls associated with performing adhesion evaluations, and finally, specific items to be reported when conducting an adhesion test. In addition, we'll briefly describe any special requirements associated with conducting adhesion testing of coatings applied to concrete substrates. Note that this webinar is not meant to replace or be a substitute for information and procedures described in the ASTM methods or the instrument manufacturer's instructions. It provides an overview of basic adhesion testing methods. Prior to performing adhesion testing, you should carefully read the instrument manufacturer's instructions and the ASTM test methods to ensure a complete understanding of the procedure. Also, calibration of the pull-off adhesion testing devices is not described in this webinar. You should follow the manufacturer's instructions for frequency of calibration. This is typically performed by the equipment manufacturer or an accredited calibration laboratory. We have 12 outcomes associated with this webinar. Completion of this webinar will enable you to explain why coatings may be assessed for adhesion properties, describe 2 adhesion testing mechanisms, be able to list 4 ASTM test methods for evaluating adhesion, be able to describe the basic differences between shear or peel-back adhesion and tensile or pull-off adhesion, measure the adhesion using a tape method, and measuring the adhesion using the knife method. You should also be competent in describing the basic difference between adhesion testers that are fixed alignment versus those that are self-aligning. You should be able to explain the difference in procedures when evaluating coating adhesion on concrete versus coating adhesion on steel. Measure the tensile adhesion of coatings using 5 different adhesion testers, including 1 fixed alignment tester and 4 self-aligning testers. You should be able to list common pitfalls associated with performing adhesion testing on coatings, evaluate and document planes of separation or locations of break, and you should be comfortable describing documentation requirements for adhesion testing. While hands-on learning cannot be done in a webinar, it is highly recommended that you practice with instrumentation prior to actual use. So the first question that's posed is, why are we interested in assessing the adhesion of a coating or a lining system? Well, first and foremost, the painting specification may invoke a requirement for a minimum adhesion value or rating prior to placing the structure into service. In this case, as long as the adhesion of the coating exceeds the minimum specified value or rating, the actual adhesion value or the point of adhesion loss isn't that critical. Section 6.4 of the Tri-Society Coating Specification for thermal spray coatings, or metallizing, invokes a requirement for tensile bond measurements using a self-aligning adhesion tester and provides minimum tensile bond requirements based on the type of wire used to perform the thermal spray. Adhesion testing is a valuable tool for determining whether an existing coating can withstand the stresses of an overcoat system, or whether total removal and replacement of the existing system is a better maintenance strategy. In fact, deciding to overcoat an aged coating without performing some type of adhesion assessment of the existing system is risky and can lead to coating failure. Despite all of the benefits of adhesion assessments, there is no direct correlation between adhesion ratings or values and coating system performance. That is, a coating system with a rating of 5 is not necessarily going to last twice as long as a coating system with a rating of 2 or 3. And a coating with a pull-off strength of 1500 psi is not necessarily going to perform 3 times longer than a coating system with, say, 500 psi tensile strength. In fact, both systems may perform equally even if the adhesion values are dissimilar. While the coating system must remain attached to the substrate in order to protect it, the degree of attachment can vary. When you perform an adhesion test, you are measuring the strength of a coating at several different planes. First, you are testing the adhesion of the coating system to the substrate. Second, you are testing the adhesion of the coating layers to each other, if there is more than one layer of coating on the surface. In both of these cases, you are testing the adhesion or adhesive strength of a coating, or the bond of the layers to one another and to the substrate. Finally, when you perform an adhesion test, you are testing the inner strength of each coating layer. This is known as the cohesion or cohesive strength of a coating, or the ability of each layer to hold itself together. We will illustrate each of these in more detail later. The adhesion of a coating system to a surface is highly variable and can be influenced by a multitude of factors, way too numerous to itemize during this webinar. That is probably why there is no industry-wide standard that says that a certain generic type of coating must have a minimum adhesion or cohesion strength. However, project specifications may require a minimum adhesion value as a contract requirement, and coating manufacturers will often report an adhesion value on their product data sheets. Sometimes this value is adopted into a project specification. Prior to performing an adhesion test, you must select a test method. The project specification should indicate the required method, as the various methods can generate very different results. There are 3 primary ways to test the adhesion of a coating system, including tape, knife, and pull-off. The 3 methods are described in 4 ASTM standard test methods. The chart on the slide lists the methods that are commonly used to test the adhesion of industrial coatings. Generally, the tape and knife methods are considered field test methods since they do not require any special equipment and can be conducted rather quickly. Tensile or pull-off adhesion requires instrumentation and takes comparatively longer to perform. However, the instruments used to test pull-off adhesion strength of coatings are portable, and testing can and is routinely performed in the field. The tests described in this webinar evaluate 2 different adhesion properties, and they use different testing mechanisms. The tape and knife adhesion tests are used to evaluate the shear or peel strength of a coating, while the pull-off test is used to evaluate a coating's tensile strength or its resistance to a perpendicular pull. Since the testing mechanisms are different, the results obtained from each test should not be compared. Also, any type of adhesion test is destructive. That is, the coating in the area in which you perform the test will be damaged and oftentimes must be repaired. Non-destructive pull-off adhesion testing can be performed by applying the load up to but not exceeding the contract specified tensile force. The load can be decreased and the fixture left on the coated surface, provided the contract permits this practice. If the project specification or other document requires you to perform an adhesion test according to ASTM D3359, which is the adhesion by tape test, you will need the testing equipment listed on the slide. This includes a steel ruler or crosscut template, a utility knife equipped with a new blade, a small bristle brush, adhesive tape, a magnifier, and a copy of the ASTM test method. A cross-cut tester equipped with cutter blades of various spacings can be used in lieu of a template or guide and a knife blade. Selecting a test area is perhaps the most difficult part of adhesion testing, particularly if you are evaluating an older coating system that has been maintained by touch-up painting over many years. It is well beyond the scope of this webinar to provide direction on where to test and how many tests to perform. However, you should test several areas and perform triplicate tests in each area to ensure you are obtaining representative adhesion data. If you are testing the adhesion of a new coating system, you may want to minimize the number of locations that you test to reduce the amount of touch-up required. Before you test the adhesion of the coating system using this procedure, you will need to determine how thick the coating system is. This will enable you to select a testing method. Method A is called an X-cut and is used to test the adhesion of a coating system that is greater than 5 mils thick. Method B is called a cross-cut and is used to test a coating system that is less than or equal to 5 mils thick. If method B is selected, the spacing between the incisions varies depending on the coating thickness. If the coating is less than 2 mils thick, the cuts are spaced 1 millimeter apart and 11 incisions are made. If the coating is between 2 and 5 mils thick, the cuts are spaced 2 millimeters apart and 6 incisions are made. This procedure will be described later. To perform method A, mount the new razor blade in the utility knife. Use a straight edge and make a 1.5 inch long cut through the coating system down to the substrate, then make a second 1.5 inch long cut across the first cut to form an X. The legs at the top and bottom of the X should be approximately 1 inch apart. The intersection of the X should be a 30 to 45 degree angle. Remove any debris from the X area using a soft brush. Remove 2 complete wraps of adhesive tape and discard it. Carefully remove a 3-inch piece of adhesive tape and apply it to the X area. Because the tape and the X cut area are both 1 inch wide, the tape should cover the entire X cut. Use a soft pencil eraser to rub the tape over the X cut. 60 to 120 seconds after applying the tape, remove it from the X cut smoothly and rapidly 180 degrees back across the X cut. Do not pull the tape upwards. Examine the X cut for coating delamination. Since there will be shavings of coating down in the grooves of the cuts, it is not a good idea to rate the adhesion based on what appears on the tape, since the tape will almost always have coating debris on it. Instead, look at the X cut on the coated surface and rate the condition of it according to the rating scale in the ASTM standard, which is shown on the slide. A rating of 5A indicates excellent adhesion, while a rating of 0A indicates very poor adhesion. If possible, the location of break should also be recorded as adhesive, which is a split between 2 layers or between the substrate and the first layer, or cohesive, which is a split within a single layer of coating. To perform method B, mount a new razor blade in a utility knife. Use a guide or template to make a series of 6 or 11 parallel knife blade cuts through the coating system down to the substrate. The number of cuts and amount of space between the cuts is based on the total thickness of the coating system, as we described earlier. Alternatively, a cutter blade with predetermined spacing can be used. Turn the guide or template 90 degrees and make a second series of parallel knife cuts over the first set of cuts, but make them perpendicular to the first set to form a grid, crosshatch, or crosscut pattern. Remove any debris from the crosscut area using a soft brush. Remove 2 complete wraps of adhesive tape and discard it. Carefully remove a 3-inch piece of adhesive tape and apply it to the crosscut area. If the total width of the crosscut area is more than 1 inch, you will have to apply a second piece of tape next to the first piece to cover the entire grid area. Make sure that you overlap the 2 pieces so that you can pull them from the grid simultaneously. Use a soft pencil eraser to rub the tape over the crosscut area. This will help ensure a good contact between the tape and the coating. Within 60 to 120 seconds, grasp one end of the tape and remove it from the crosscut area smoothly and rapidly 180 degrees back across the grid. Peel the tape back, do not pull it upwards. Examine the crosscut area for coating delamination. Since there will be shavings of coating down in the grooves of the cuts, it is not a good idea to rate the adhesion based on what appears on the tape, since the tape will almost always have coating debris on it. Instead, look at the crosscut area of the coated surface and rate the condition according to the scale in the ASTM standard. The standard also provides a corresponding chart that illustrates the various percentages of delamination. A rating of 5B indicates excellent adhesion, while a rating of 0B indicates very poor adhesion. Again, if possible, the location of break should also be recorded as adhesive or cohesive. Adhesion can also be evaluated using ASTM D6677, which is evaluating adhesion by the knife test. If the project specification or other document requires you to perform this test, you will need the testing equipment listed on the slide. This includes a steel roller, a utility knife equipped with a new blade, and a copy of the ASTM test method. You do not need adhesive tape for this method. To perform the knife adhesion test, select a test area, then mount a new razor blade in a utility knife. Use a straight edge and make a 1.5 inch long cut through the coating system down to the substrate, followed by a second 1.5 inch long cut across the first cut to form an X. The legs at the top and bottom of the X should be approximately 1 inch apart. The intersection of the X should be a 30 to 45 degree angle. Starting at the intersection of the X, use the tip of the knife blade and attempt to lift the coating from the substrate or the underlying coating layers. Rate the adhesion according to the table in the ASTM standard, which is shown on the slide. A rating of 10 indicates excellent adhesion, while a rating of 0 indicates very poor adhesion. If possible, the location of break should also be recorded as adhesive or cohesive. There are 6 pitfalls to avoid when performing this type of tape or knife adhesion testing. First, the scope of ASTM D3359 standard applies to testing coatings on metallic surfaces. While similar testing can be performed on wood and plastic, the standard really wasn't designed for this purpose and should be done with caution. Incisions created with dull knife blades can produce chatter along the cut lines, and it can result in a lower adhesion rating. When conducting method B, the spacing between the incisions is critical. If the cuts are too close, the coating may ribbon off of the surface. When conducting method A, make sure the distance between the top 2 legs and the bottom 2 legs of the X is 1 inch, which will create the 30 to 45 degree angle required by the standard. Since different tapes and different lots of tapes can produce different results, it is important to report the manufacturer and type of tape employed, and all testing should be performed using tape from the same lot. Many adhesive tapes are adversely affected by extreme temperatures or relative humidity. The temperature of the air and surface, as well as the relative humidity at the time of testing, should be recorded. So which tape is the correct tape to use? Well, that's a good question. Note 5 in the 2009 version of the tape adhesion standard stated that Permacell 99 was found suitable for use. It wasn't required, but it was found suitable for use. Unfortunately, this tape was discontinued in 2009 and is no longer available. However, at least 3 manufacturers of coating inspection instruments now produce a tape that is suitable for use with the standard. Recording of the data acquired during tape and knife adhesion testing includes the type of substrate, the coating or coating system and method of cure, the air and surface temperature, as well as the relative humidity during testing, the number of tests performed, the manufacturer and type of tape used. Of course, this applies only to the tape adhesion test, the average and range of adhesion ratings, and the location of break if it is discernible. ASTM D4541 describes the procedures associated with evaluating tensile or pull-off adhesion of coatings applied to metal substrates. There are 5 annexes in the standard describing the apparatus and procedures for 1 fixed alignment tester and 4 self-aligning test devices, including 3 hydraulic and 1 pneumatic tester. The standard also provides the results of an interlaboratory study performed back in 2008 that demonstrates the variability in test data generated by different test devices. It is important to determine which devices were used to perform testing prior to performing comparative pull-off adhesion values. Once a test area is selected, you may need to prepare the surface prior to attaching the loading fixtures. Ensure the area selected is free of grease, oil, dirt, or chalking, water, protrusions, or other conditions that will interfere with the attachment of the loading fixture. The area selected must also be flat and rigid and be large enough to accommodate the test apparatus as well as the attachment of triplicate loading fixtures. According to the standard, a substrate thickness of less than 1/8 inch usually causes a reduction in adhesion compared to a 1/4 inch substrate thickness, so rigidity of the substrate is an important consideration. If the test surface is very smooth or glossy, you may elect to lightly roughen it using fine grades of sandpaper. If you abrade the surface, be sure to wipe away any fine dust that was created using a solvent that will not affect the coating. There is no standard design for loading fixtures, or dollies as they are sometimes called. The loading fixtures are designed to be compatible with the test device. The loading fixtures for the Type 2, Type 4, and Type 5 are aluminum and are generally used once then discarded. The Type 3 loading fixture is stainless steel and the Type 6 fixture is carbon steel. These fixtures can be cleaned and reused. While the aluminum fixtures can be cleaned and reused, it may be more economical to simply purchase new ones. Because the contact surface of the loading fixtures is smooth, you may need to roughen it using a coarse sandpaper or an abrasive pad. Type 2 loading fixtures are available pre-roughened by abrasive blast cleaning, and Type 4 loading fixtures are supplied pre-roughened by abrasive blast cleaning. Independent of whether you use pre-roughened loading fixtures or roughen them just prior to use, it is important to remove any dirt or debris that may interfere with the attachment of the fixture to the surface. There are a variety of adhesives that can be used to attach the loading fixture to the surface. A 100% solids epoxy adhesive is often used, but many require an extended cure time and minimum temperature to achieve complete cure. While other quick-set adhesives are available and can be used, they may not be able to withstand the pulling forces of the test device and may break before the coating does at a relatively low force. Cyanoacrylate adhesives or superglues may soften or penetrate the coating film, so their use may be restricted on certain coatings. It is recommended that you test the coating in an inconspicuous area to assess compatibility between the adhesive and the coating if you're unsure whether the adhesive will affect the coating. The Type 4 tester is available with specially designed loading fixtures which use an adhesive that cures using an ultraviolet light source. Because the adhesive cures more rapidly, adhesion testing can be initiated more quickly. To attach the loading fixtures, mix the adhesive you selected according to the manufacturer's instructions. If the adhesive is two-component, it will have a minimum working time. It will have a maximum working time, so mix only as much as you anticipate using during the working time. Using a wooden stick, apply an even layer of adhesive to the entire contact surface of the loading fixture. The addition of about 1% number 5 glass beads to the adhesive assists with even alignment of the fixture to the surface. However, the addition of glass beads is not mandatory. Attach the loading fixture to the coated surface and gently push downward to displace any excess adhesive. Never twist or slide the fixture during attachment because you can generate air bubbles in the adhesive. Carefully remove the excess adhesive from the perimeter of the fixture using a cotton swab or other device. The Type 4 tester comes with clear masks containing a center hole that are placed on the surface prior to attaching the fixture. Any excess glue is deposited onto the mask instead of the coated surface. Allow the adhesive to fully cure before performing an adhesion test. To attach the Type 3 loading fixtures, insert the small diameter Teflon plug through the center hole of the stainless steel fixture until the small tip of the plug protrudes from the contact surface of the fixture. Using the adhesive dispenser bottle or a wooden stick, apply an even layer of adhesive to the entire contact surface of the fixture. Attach the fixture to the coated surface and gently push downward to displace any adhesive. Remove the Teflon plug from the center of the fixture and remove any adhesive that has accumulated on the end of the plug. The ASTM standard recommends applying constant pressure on the fixture until the adhesive sets. This is particularly important when the fixtures are attached to vertical surfaces, as they will likely slide down the surface before the adhesive has an opportunity to set. A magnetic or mechanical device may be used. However, adhesive tape is more common. If tape is used, it should be routinely inspected to ensure it doesn't relax over time and allow air to enter the fixture-to-surface interface. While light scoring can be used to remove excess adhesive from the perimeter of the loading fixture, the ASTM standard does not recommend scoring the coating down to the substrate prior to testing. Scoring may produce tiny fractures in the coating or may generate friction heat, which can change the properties of the coating and result in lower adhesion values. If the project specification requires you to score the coating, it must be done very carefully to avoid contact with the sides of the fixture. Scoring is recommended for elastomeric coatings, reinforced coatings, and coatings that are applied greater than 20 mils thick. If you score around the perimeter, place the scoring device over the fixture and rotate the cutter using a back and forth motion. Make sure you score down through all coating layers of the substrate. For thick coatings, you may need to use a hole saw mounted in a portable drill to penetrate down to the underlying substrate. This requires considerable skill to avoid contacting the sides of the fixture. A wood template with a pre-drilled hole may help prevent sideways movement of the hole saw. Alternatively, the coating can be scored prior to placement of the loading fixture. If the coating is scored, it should be reported with the test results. Now that the fixtures are attached, I'll describe the use of 5 pull-off testers, starting with the Type 2 device. The Type 2 tester is a fixed alignment device and is available in various ranges. 3 of the 6 models employ a spanner wrench to tighten a nut and apply the force, as opposed to a hand wheel. And 1 model is specifically designed for use with 2-inch diameter fixtures for testing of coatings on concrete. The Type 2 adhesion tester consists of 3 components: a hand wheel or a hex nut at the top of which is used to apply the force, a black column containing a dragging pin and scale in the middle, and a base containing 3 legs and a pulling jaw, which is designed to fit around the head of the loading fixture. Step 1, the adhesion tester is attached to the loading fixture by rotating the hand wheel or hex nut counterclockwise to lower the jaw of the device. Step 2, the jaw is positioned completely under the head of the fixture. Step 3, the 3 legs are positioned so that they are sitting flat on the coated surface. And step 4, the drag pin indicator is positioned to 0 on the black column by pushing it downward. This is indicated by the red arrow on the slide, image 4. Firmly hold the base of the instrument in one hand and rotate the hand wheel clockwise to raise the jaw of the device that is attached to the head of the loading fixture. If the adhesion tester is equipped with a hex nut at the top, use the spanner wrench supplied with the tester. The tension on the spring will place a perpendicular upward force on the fixture. The dragging pin indicator will move upwards on the black column as the force is increased and will hold the reading once the force is released. Increase the tension smoothly and evenly using a moderate speed. The rate of force should not exceed 150 psi per second. Continue to increase the tension on the head of the fixture until the test is complete, ideally in 100 seconds or less. The black column near the middle of the adhesion tester contains two scales. The right scale is pounds per square inch, and the left scale is megapascals. When the end point of the test is reached, the scale across from the bottom of the dragging pin indicator is red. When using the PSI scale, multiply the scale value by 100. For example, if the bottom of the dragging pin is at 6 on the PSI scale, the value is recorded as 600 PSI. The Type 3 adhesion tester is self-aligning and consists of a black threaded hand lever, a pressure indicator dial containing a black needle and a red sweep needle, a flexible hydraulic hose, a stainless steel cylinder, and a quick connect locking ring with a stainless steel pin protruding from the center. A digital pressure indicator display is also available. Attach the adhesion tester to the fixture by rotating the black threaded hand lever counterclockwise to retract the stainless steel pin. Insert the center stainless steel pin through the center of the pull stub, or loading fixture. Then attach the quick connect locking ring to the fixture by pulling back on the snap-on ring and locking the ring onto the flange of the fixture. Pull slightly upward on the adhesion tester to ensure it is engaged onto the fixture. Rotate the red sweep needle dial to 0 or depress the 0 key on the digital display. The black hydraulic hose must remain straight during testing. Hold the knurled knob of the tester in one hand and rotate the black threaded hand lever clockwise. This will cause the center pin to push against the coated substrate and the locking ring to simultaneously pull upward on the fixture. The black and red indicator needles will rotate on the scale, or the digital display value will increase as the force is increased. The black needle will return to 0 when the pressure is released, but the red sweep needle will hold the reading. Of course, the digital version will display the maximum force until the display is reset with the 0 button. Increase the tension smoothly and evenly using a moderate speed, again no faster than 150 psi per second. Continue to increase the tension until the test is complete, ideally in 100 seconds or less. After the loading fixtures are evaluated, they can be cleaned and reused. The Type 4 adhesion tester is also self-aligning and consists of 3 basic components: an adhesion tester base component, an air hose, and a piston. Compressed air is deployed at a constant rate to the piston. The top plate of the piston is threaded onto the shaft of the loading fixture, creating a perpendicular pull. The piston burst pressure is converted to PSI or kilopascals using conversion charts, which are based on the fixture diameter and the piston size. The piston itself contains 3 parts: a round base with a short pigtail hose and a threaded connector, a silicone rubber gasket inside the piston base, and a round black threaded top plate. There are 6 pistons to choose from. The F2, F4, and F8 are the more common piston sizes for testing industrial coating systems. Select a piston, then connect it to the longer blue hose using the brass coupling. Insert the opposite end of the blue air hose to the port on the base component. Insert the air cartridge into the black sleeve. Thread the sleeve containing the air cartridge onto the port of the base component. You will hear a hissing noise as the tip of the cartridge is pierced and pressurized air enters the base component. Hand tighten the sleeve until it is snug. Place the piston base over the threaded end of the fixture until it is flush with the coated surface. Make sure the silicone rubber gasket is seated inside the piston base. Carefully thread the black plate onto the fixture until the top plate remains in contact with the piston base. Then reverse the black plate 1/4 to 1/2 turn so that a small gap is created between the piston base and the top plate. Close the rate valve, but do not over-tighten it. As you see in the diagram on the lower right on the slide, compressed air traverses through the hose and enters the piston at a point underneath the silicone gasket, causing the gasket to elevate and impart force to the underside of the top plate. Since the top plate is threaded onto the loading fixture, upward force is applied at a constant rate of pull. To operate the tester, verify the unit is powered up and depress the peak reset button. Push in and hold the run button while simultaneously opening the rate valve until the pressure increases at a rate of approximately 2 psi per second without exceeding 6 psi per second. When you achieve the endpoint of the test, read and record the burst pressure from the display. Convert this value to psi or kilopascals or KPA using a piston pressure conversion chart. Each piston size has a unique chart. There are 2 charts for each piston range. One chart converts the burst pressure to pull-off strength in psi, and the other chart converts the burst pressure to pull-off strength in kilopascals or KPA. The F4 piston chart is shown. The left-hand column on each chart contains bold numbers 10 through 100. The top row contains bold numbers 0 through 9. You can use these values on the chart to plot the burst pressure and convert it to pull strength. For example, if an F4 piston was used and the burst pressure was 46 psi, you would move down the left column and locate the bold value 40, then move across the top row and locate the bold value 6. Intersect the 40 and the 6 and record the psi value from the chart, which is 937.3 psi. The Type 5 adhesion tester is self-aligning and consists of 2 basic components, an adhesion tester base component and an actuator. The base component contains a hydraulic cylinder with a pressure release valve, a lever and a pressure gauge. The design of the head on the loading fixture ensures a perpendicular pull even when the loading fixture is not attached flush to the surface. This is shown in the bottom right-hand image on the slide. To operate the tester, verify that the pressure relief valve on the cylinder is completely open, then push the black actuator handle completely down into the actuator assembly. Power up the test device and verify the display reads 0. If it does not, press the on-off button to zero the display. Select the fixture size and the units by pressing the corresponding buttons on the control panel. Place the actuator assembly over the round head of the fixture and attach the quick connect coupling to the loading fixture. Close the pressure relief valve on the pump tightly. Begin pumping the lever above the cylinder until the pressure increases. Continue pumping at a uniform rate of no more than 150 psi per second until the actuator detaches the fixture from the coating. The display contains a pull rate monitor bar directly above the pressure reading. The display will hold the maximum pressure reading for you until you clear it. Either record the value or press the memory pad on the control panel to store the value. Press the green on-off button to zero the display. An automatic version of the Type 5 adhesion tester eliminates the need for pumping a lever to apply the hydraulic load to the fixture. This is done automatically. The Type 6 adhesion tester is self-aligning and uses hydraulic pressure to slowly and constantly increase the perpendicular pull on an attached loading fixture. This pull-off strength is read directly from the gauge in pounds per square inch or megapascals. The testing head shown in the slide has a pressure capacity of 17 MPa which is approximately 2,470 psi. The Type 6 adhesion tester consists of two basic components, a turning crank and a testing head. Verify that the crank and the tightening wheel are in the start position. Press the 4 testing head pistons against an even surface using hand pressure. This will return the hydraulic oil to the pump and prepare the equipment for testing. Lift the outer ring of the testing head's quick release coupling and mount the testing head onto the loading fixture. Release the quick connect and listen for the click, indicating that the quick connect has locked into the groove near the top of the fixture. Return the red sweep needle to 0. Turn the tightening wheel at the base of the pump until all 4 of the piston legs on the testing head are fully in contact with the coated test surface and the pointer on the gauge dial begins to move slightly. Turn the hand crank smoothly and evenly until the desired pressure is reached or until the coating fractures. The pressure gauge dial of the adhesion tester contains 2 scales. The black outer scale is in megapascals and the inner red scale is in pounds per square inch. The red sweep needle will hold the maximum value until you return it to 0. Read and record the value from the pressure gauge. If the PSI scale is used, multiply the value by 100. If the metric scale is used, no conversion is required. The procedures used to test the pull-off adhesion of coatings on concrete are very similar to the procedures used to test the pull-off strength of coatings on steel. However, there is a different ASTM method for testing coatings on concrete, and there are a few minor differences in the equipment and procedures. I'll highlight the major differences between testing coatings on steel and testing coatings on concrete. If you intend to conduct this type of testing of coatings on concrete, you should review the ASTM standard prior to performing the testing, as I'm only covering a few of the variations in the procedure. The appendix to SSPC SP13 on surface preparation of coating concrete describes procedures for testing adhesion of coatings to concrete, and SSPC's Concrete Coating Inspector course provides training on adhesion testing procedures. I'll be focusing on 4 basic considerations: scoring, loading fixture size, loading rate, and compressive versus tensile strength. First, we'll discuss scoring of the coating. Thick film coatings greater than 20 mils may have lateral bond strength, which can produce misleading pull-off values. Therefore, you will likely need to score the coating down to the concrete prior to attaching the loading fixture. Scoring a coating on concrete that is less than 20 mils in thickness may also be required. Scoring can be done by hand if the coating is thin enough. For very thick coatings, a mechanical method of scoring the coating may be required. Independent of the scoring method you select, you will need to score the coating prior to attaching the fixture. Otherwise, you may inadvertently shear it off. When attaching the fixture to the surface, make sure that any excess glue does not flow into the score groove. The second consideration is loading fixture size. Unlike steel, concrete is a heterogeneous or non-uniform substrate that contains cement, paste, and an aggregate. While any diameter loading fixture can be used, a 2-inch or 15mm diameter fixture is recommended so that the adhesion strength of the coating is being evaluated or for a representative surface. Square loading fixtures are used with some test devices. The third requirement is regarding loading rate. The loading rate applied to the fixture by the adhesion tester should be approximately 30 psi per second so that the test pull is complete in 5 to 30 seconds. The fourth special requirement is compressive versus tensile strength. Concrete has extremely high compressive strength, typically in excess of 4,000 psi, but relatively low tensile strength, typically less than 400 psi. Therefore, it is quite common to get a relatively low value when you test coatings on concrete, and the plane of fracture is typically within the concrete substrate since the concrete tensile strength often exceeds since the coating tensile strength often exceeds the concrete tensile strength. In this case, the minimum coating adhesion pull-off strength can be reported, but the actual coating strength is unknown. In addition to recording the pressure, the type and location of break should be described. An adhesive or adhesion break is defined as a break between coating layers or between the substrate and first coating layer. A cohesive or cohesion break is a break within a single coating layer, and a glue break is used to describe an occurrence where the coating adhesion or cohesion strength exceeds the bonding strength of the adhesive used. If multiple locations of break occur, estimate the percentage of each. Image 1 on the slide illustrates a 100% adhesive break between the top coat and the primer. Image 2 illustrates a glue break, while image 3 illustrates a cohesive break within the primer layer. Image 4 illustrates an adhesive break between the substrate and the primer, while image 5 illustrates a cohesion break within the top coat. According to the ASTM test method, any pull test that results in a glue failure of more than 50% of the loading fixture surface should be discarded. If an adhesion acceptance value is provided and a glue break occurs, reattachment of new loading fixtures is only necessary if the pull-off value is below the acceptance value. If the glue break occurs at a pull-off rate higher than the acceptance value, then no retesting is necessary, even though the actual pull-off strength of the coating remains unknown. Here are some common pitfalls to avoid when performing adhesion testing. First, the ASTM standard discloses the variability in test data generated by different test devices. It is important to determine which devices were used to perform testing before you compare pull-off adhesion values. Second, calibration of test devices varies by manufacturer. Vary the currency of calibration before you perform any testing. Third, a minimum of 3 loading fixtures should be applied in each area. 4. The substrate thickness less than 1/8 inch may cause a reduction in adhesion since the substrate may be flexing while the load is being applied to the fixture. 5. Oil or debris on the coating surface or on the contact surface of the loading fixture can result in glue breaks. Careful cleaning of these contact surfaces is important. Glossy surfaces may be lightly abraded to enhance the bond of the glue to the coated surface, but excess abrading may alter the coating. 6. Verify that the adhesive will not dissolve the coating by testing it in an inconspicuous area. 7. Follow the adhesive manufacturer's directions regarding cure time and temperature to avoid glue breaks at low values. 8. Verify that the loading fixture is attached flush to the surface to ensure a perpendicular pull. Self-aligning adhesion testers can compensate for some unevenness. Finally, 9. Attachment of the test device to the loading fixture on a vertical surface can apply lateral forces to the fixture, resulting in a shear effect. Carefully support the test device when it is used in this manner. Recording of the data acquired during pull-off adhesion testing includes the substrate type, the coating or coating system and the thickness, the type and test surface orientation, whether the testing was performed in the field or in a laboratory, the air temperature and relative humidity during testing, the test apparatus along with the loading fixture type and size, the type of adhesive used, the number of tests performed, the load that was applied, the average and range of pull-off values, the location of break, And finally, a note as to whether scoring was employed or whether there was any other deviations from the standard test method. Thank you for listening to this webinar on coating adhesion testing methods and equipment. To enjoy viewing other videos and webinars like this one, visit the Digital Learning Series tab on KTAUniversity.com.